Hi, my name is Alvin, and we are our team Facial Analysis for Communicating Expressions. Our mentors are Dr. Ramesh Lapa, Dr. Chaman Tang, our graduate mentor is Lee Stearns, and our librarian is Mr. Jim Miller. Now first, I want you guys to imagine that you guys are having a conversation with a friend. Let's say a guy friend. I'm sorry. When he smiles, generally you know he's happy. When he frowns, you know you may have said something that made him upset. But what if you were blind? What if you could not see these expressions? Would that change how you communicate? Well, we went and asked a few blind individuals about how important expression recognition is to them. This is what one of them said. I have to think through those faces to see if they're angry, happy, or disgusted. I want to see if what I said upset them or made them happy or sad. Sometimes I can tell with tones, but not all the time. Visual cues play an integral role in verbal communications. In fact, studies have shown that 68% of all communication between two people is nonverbal. Now consider that there are 11.4 billion people with visual impairments just in the United States. While we realize that we cannot restore sight, we can most definitely try to restore the ability to sense expressions. So, to briefly outline our presentation, we'll begin with a quick background, followed by a discussion of our development cycle. Then we'll talk about our timeline and then give some advice for the Gemstone freshman. So as a team, we asked ourselves this question. How can technology be used to improve interactions between the visually impaired and sighted individuals? We hypothesized that the use of computer vision to analyze and relay nonverbal cues during any interaction would improve the quality of communication and provide useful and novel feedback to the visually impaired. Essentially, we want to use computer vision as assistive technology to the blind. Now you're probably asking yourselves, or some of you, what is computer vision? Well, I'll tell you. Computer vision is the combination of computers and optical devices that mimic human eyesight. Some interesting developments in computer vision technology have included the capacity to recognize faces, much as a person recognizes the people they interact with on a regular basis. So we got a video coming up for you. When the computer stops reading. So you see in this video, computer vision can even be used to identify expressions by tracking the various components of the face, like his eyebrows and his mouth. You can also see that the software is outputting the expression with his face. Now I'll pass it on to Melissa for the methodology.
Thank you, Alvin. So in order to answer our research question, we're using a product design methodology, and that's composed of 4 separate phases. So the first phase is idea generation, and then we'll move on to design, prototyping, testing, and then once we receive our feedback from testing, we head back to the idea generation phase and continue through the cycle again. So within idea generation, we started with brainstorming, sitting down, and coming up with how we could tackle and answer our research question. And then we actually had a meeting with the National Federation of the Blind, and we got a lot of helpful feedback from them because those individuals are visually impaired. And then we sat down, we evaluated our ideas so far with internal evaluation. So we evaluated so far what we've been thinking of, also looking at previous literature to see what other people have used to tackle the problem. And then in addition to that, some external evaluations. We had some cited surveys and interviews with the visually impaired community. So with our cited surveys, we had a population of 98 individuals ranging of 18 to their mid-60s. And as you can see in this graph, our population, or the majority of them, either never or rarely interacted with the visually impaired. And then after we asked them what their frequency of interaction was, we wanted to see their perception, because something that was brought up in the meeting with the National Federation of the Blind was that they were concerned of how the sighted community would view and perceive them using such a device. So the first question we asked was how would they react if they saw a blind individual using the device. And as you can see, the vast majority were intrigued. That's the blue bar. And they were interested in it, and they gave fairly positive feedback on the system. But then when we asked a follow-up question, we wanted to know how they would react if they knew such a device was analyzing their face. You can see there's a jump with the green in the number of sighted survey participants that thought that they would be either initially uncomfortable or uncomfortable with that happening. And then our final question that we asked the sighted survey participants were if they thought such a device would negatively impact their interaction